A lawyer submits a flawless legal brief to a federal judge citing 6 distinct judicial precedents. The document is impeccably formatted, the arguments are logically sound, and the case law perfectly supports the motion. There is only one problem: none of those cases actually exist. The citations, the docket numbers, the judges' names, and the rulings were entirely fabricated by an artificial intelligence. This is not a glitch in the traditional sense, but a fundamental feature of how modern algorithms operate. It is the defining vulnerability of our new digital era, a phenomenon known as the AI hallucination. The danger of these fabrications lies entirely in their presentation. When large language models generate false information, they do not stutter, hesitate, or include warning labels about their uncertainty. Platforms like ChatGPT deliver these fictions with the exact same authoritative tone and structural perfection as they do verified facts. The illusion of competence is absolute. Because the output reads as though it were written by a highly educated human expert, our natural instinct is to trust it, making the deception exponentially more dangerous than a simple search engine error. To understand why this happens, we must strip away the anthropomorphic traits we project onto these machines. These systems do not possess a database of facts or a repository of human knowledge. They do not reference a mental encyclopedia before they speak. Instead, they operate on a vast, multidimensional statistical map of language. They are mathematical engines designed for one specific task, which is predicting the next most probable token or piece of a word in a sequence. When you submit a prompt, the model calculates probabilities across billions of parameters to determine which word should logically follow the last. It is a highly sophisticated form of autocomplete, optimizing strictly for linguistic fluency and coherence. Factual accuracy is merely a frequent byproduct of this process, not its primary objective. If the most statistically probable next word aligns with the truth, the system appears knowledgeable. If the most probable word forms a plausible lie, the system generates a hallucination without any awareness of the difference. The foundation of this predictive power lies in the transformer architecture, a breakthrough that allowed neural networks to track the context of words over incredibly long passages. This attention mechanism is what gives the output its remarkable human-like flow. But this exact same architectural brilliance is what enables the system to weave complex, internally consistent fictions. It remembers the fake premise it established in paragraph 1 and builds upon it flawlessly in paragraph 4, creating a narrative trap that is incredibly difficult for a human reader to detect. The probabilities that drive these predictions are derived from the model's training data. To build these digital minds, tech companies scraped the vast, unfiltered expanse of the public internet. They fed the algorithms millions of books, articles, forums, and websites, absorbing the collective output of humanity. This corpus is unimaginably massive, but it is also deeply flawed, containing fiction, speculation, outdated science, and outright falsehoods alongside verified information. The model digests it all, mapping the relationships between words without any inherent mechanism to verify their connection to physical reality. When the algorithm encounters a gap in its statistical map, a subject where its training data is sparse or contradictory, it does not pause to request clarification. The architecture demands that the sequence continue. To bridge the void, it extrapolates, pulling together fragments of related concepts to synthesize a response that sounds correct. It fills the silence with highly probable, yet entirely fabricated tokens. This is the mechanical reality behind the hallucination, a mathematical extrapolation pushed beyond the boundaries of its grounded knowledge. The implications of this architectural quirk are actively disrupting high-stakes industries. In clinical research settings, experimental diagnostic tools have been observed, suggesting non-existent chemical compounds for treatments. The models generate these phantom drugs because the syllables fit perfectly into the established linguistic patterns of medical terminology. To a layperson, the output looks like a breakthrough. To a biochemist, it is a dangerous illusion, a string of text that mimics science without being bound by the laws of chemistry. Similarly, financial analysts have received automated earnings summaries populated with phantom revenue streams and fabricated merger announcements. The models synthesize numbers and corporate jargon that perfectly resemble actual financial data but represent nothing in reality. When millions of dollars move based on algorithmic sentiment analysis, a single hallucinated corporate event can trigger cascading market reactions before a human can verify the source. The seamless integration of these tools into enterprise workflows has turned a mathematical quirk into a systemic vulnerability. Explaining this vulnerability to the general public is the most critical challenge facing the industry today. The illusion of a reasoning mind makes us uniquely vulnerable to manipulation. We have spent our entire evolutionary history associating mastery of language with cognitive understanding and consciousness. When a machine speaks beautifully, we subconsciously assume it is thinking rationally. Breaking this psychological association is essential for maintaining AI reliability in the public sphere. If left unchecked, this phenomenon threatens a broader erosion of societal trust. If a widely deployed machine can generate infinite plausible untruths at zero marginal cost, the baseline of digital reality rapidly destabilizes. We face a looming epistemological crisis where the internet becomes flooded with synthetic hallucinations, making the act of verifying truth significantly harder than the act of generating fiction. The digital ecosystem risks becoming a hall of mirrors, where algorithms eventually train on the hallucinated outputs of other algorithms. Researchers at the bleeding edge of the field are acutely aware of this existential threat and are racing to engineer solutions. They are attempting to anchor these floating statistical maps to verifiable reality through a process called grounding. The goal is to force the probabilistic engine to cross-reference its predictions against a fixed factual database before it is allowed to generate a final output. The most prominent breakthrough in this effort is a technique called retrieval augmented generation. Instead of relying solely on the internal weights established during its initial training, the model is instructed to search a verified external repository for relevant facts when asked a question. It pulls this factual text into its immediate memory, reads the verified data, and then uses its linguistic capabilities to summarize the answer. It is essentially giving the system an open book test rather than forcing it to rely on its highly fallible, probabilistic memory. Yet, even with external grounding mechanisms in place, the core architecture remains fundamentally probabilistic. The urge to guess, to seamlessly fill the silence with a highly probable sequence of tokens, is baked deeply into its foundational design. If the retrieval system fails to find the exact fact, or if the prompt is subtly misleading, the model can still slip back into hallucination, seamlessly blending the retrieved facts with its own mathematical fictions. The fix is a patch, not a cure for the underlying condition. The rapid deployment of these systems over the last 18 months has been a grand, uncontrolled experiment on the global population. The rush to release conversational interfaces into public hands meant exposing this profound architectural flaw to billions of users simultaneously. Companies prioritized market dominance and user acquisition over strict factual fidelity, launching products that were astonishingly capable but fundamentally untrustworthy. The initial shockwaves caused by these high-profile fabrications forced a massive reckoning within the tech industry. Engineers quickly realized that simply scaling up the parameter count and feeding the model more data did not automatically cure the system of its delusions. In fact, larger models sometimes became more convincing liars, using their enhanced linguistic capabilities to construct even more elaborate and structurally sound hallucinations. Brute force computing power was not enough to solve a problem of epistemology. The immediate future of AI reliability likely depends on the development of complex hybrid systems. The next generation of models will likely incorporate separate adversarial neural networks designed purely to fact-check the generative layer in real time. One network will generate the text, while a secondary, rigidly constrained network will evaluate the output against known logical constraints and factual databases, rejecting or editing the text before the user ever sees it. This internal dialogue between a creative generator and a strict verifier mimics the cognitive checks and balances of the human brain. However, implementing this dual system architecture at a global scale requires massive, unprecedented compute infrastructure. It introduces latency into the system, slowing down the instantaneous responses that users have come to expect. The industry is currently locked in a battle to balance factual rigor with computational efficiency. Until those advanced architectures fully mature, the burden of truth falls squarely on human oversight. We must fundamentally change how we interact with these powerful interfaces. Treating a large language model as an infallible oracle or a traditional search engine is a category error that directly invites deception. They are powerful semantic engines, brainstorming partners, and pattern recognizers, but they are not arbiters of truth. The responsibility for verification cannot be entirely outsourced to the machine. Institutions, corporations, and individual users must develop robust protocols for auditing these outputs. Every citation must be checked, every metric verified, and every critical claim traced back to a primary source. The frictionless convenience of automated text generation must be counterbalanced by a rigorous, deliberate friction in how we consume and act upon that text. Despite these profound challenges, the integration of generative tools into our daily lives continues unabated. From automated customer service agents handling our finances to drafting critical emails and summarizing complex legal documents, the invisible risk of hallucination is now permanently woven into our digital fabric. We are building our modern infrastructure on top of systems that possess a fundamental, unyielding capacity for spontaneous fabrication. A single dropped negative in an automated medical summary or a fabricated date in a smart contract can trigger cascading, catastrophic failures across interconnected systems. As these models are given more autonomy to act as digital agents, executing tasks and making decisions on our behalf without direct supervision, the stakes rise exponentially. A hallucinated fact is no longer just text on a screen, it becomes an action taken in the real world. We are actively learning to coexist with a completely alien form of intelligence. It is an intelligence that dreams while awake, navigating a vast latent space of concepts where truth and fiction are mathematically equivalent. It does not understand the world through experience, but through the statistical proximity of words. Recognizing this fundamental difference is the first step toward harnessing its immense power safely. Mastering this bleeding edge technology ultimately means mastering our own credulity. We must evolve our digital literacy to match the sophistication of the tools we have created. We must build a culture of relentless verification, treating every piece of machine generated text as a rough draft, a statistical probability, rather than a final, authoritative verdict. The survival of shared truth depends on our vigilance. The era of blind, uncritical faith in the machine is over. The true frontier of artificial intelligence is no longer just generating convincing human language, but anchoring that language firmly to reality. Ensuring that the most powerful communication tools ever built actually stop making false information and speak the truth is the defining technological challenge of our time, a mission that will shape the trajectory of human knowledge for generations to come.